Today we're looking at section 3-4, solving equations that have variables on both sides. Take a look at our objectives. Our goals, we're collecting variables on one side, and then we're of an equation, then we're solving them in real life problems or models, beginning on page 154 in the textbook. An identity is the first definition we have. It's an equation that's true for all values of the variables. What that means is if you get a true statement at the end, let's say you have something that says 2x plus 2 equals 2 times x plus 1. This is an identity. The reason it is because you're going to get a true statement at the end. You're not going to get x equals a certain value here. So we know we have to distribute 2 to both of these. 2 times x is 2x, and 2 times 1 is plus 2. Notice we have the same thing on both the left and the right side of the equal sign. So if we were to undo positive 2x or plus 2x, we would subtract it on both sides, and we would be left with no more x's. Then if so it'd be like 0x, and if we undid the same thing, but we undid plus 2, we'd subtract 2 on both sides, we'd be left with something that says 0 equals 0. That's a true statement. Therefore, it's true since it's on both sides. That's considered an identity. If you have anything at the end that's a true statement, let's say we had gotten 4 equals 4 at the end. That's a true statement. Therefore, that's considered an identity. And would you represent that? You would say x's value is true. X equals all real numbers. Just 2 lines right there, and you make a big capital R. That's just every real number you could plug in that spot and make it a true statement. Example number 1, and I know on the worksheets that I handed out, there were some negatives and minuses and stuff missing, so you're going to need to fill some of these out. It says solve 4x minus 10 equals 32 minus 3x. Look at the coefficients of the x terms. On the left side, it's 4. On the right side, it's negative 3. 4 is greater than negative 3, so bring all of your x's to the left side. Some people like to bring all of their x's to the left side anyways, but that's not necessary. Usually it's easier to keep them positive, if you will. So in order to undo, and again, these blanks might have messed you up a little bit. If you ever get stuck with the blanks, just write it over here out to the side, and you can work vertically. 4x minus 10 equals 32 minus 3x. Undo minus 3x by adding it to both sides, and that's all that it shows here. It just shows it horizontally. If you add it to the right, add 3x to the left, that leaves you with 7x minus 10 equals 32, because negative 3x plus 3x would cancel itself out. And that's what we have here. 7x minus 10 equals 32. Then undo minus 10. Again, it's going to write it horizontally for you by saying plus 10. You could do it vertically right underneath it by saying plus 10 there to undo minus 10. Do the same here. 32 plus 10 is 42. We still have 7x on the left, and minus 10 plus 10 would cancel it out. So now you have 7x equals 42, or 7 times x. You undo that by dividing by 7 on both sides. Divide by 7, do the same to the right side, and you'll have x equals 6 ultimately here. X equals 6. Then it says check it to see if it gives you a true statement. 4 times x minus 10 equals 32 minus 3x. Plug in 6 in all of those spots. 4 times 6 minus 10. Is it equal or not? That's what that's asking. 32 minus 3 times 6. When you simplify it, you get 24 minus 10 equals 32 minus 18. Minus 18. 24 minus 10 is 14, and 32 minus 18 is 14. Therefore, you have a true statement at the end. 14 is equal to 14. Notice this is not an identity like we said just a second ago, because you're not solving for the variable at the end. You have x equals 6. That's it solved. At this bottom, it's just checking it, plugging it back in to see if the solution is correct. Okay, for example number 2, this is where it's many solutions or no solutions. So 2 times 4x plus 5, again, you might have some pluses or equals or something like that missing, just fill them in here. 2 times 4x plus 5 equals 8x plus 10. You have to distribute. 2 times 4x is 8x. 2 times 5 is plus 10. So we have 8x plus 10 equals 8x plus 10. Notice it's the same on both sides. So when you undo positive 8x, you would subtract it if you had written it out here to the side where you can see it. 8x plus 10 equals 8x plus 10. If you undid, or if you tried to collect all of your x's on the same side, you would subtract 8x from one side since they're the same, and subtract it from the other. It leaves you with 10, because these would cancel out. 10 equals 10. These would cancel out as well. Notice that's a true statement. If you subtracted 10 on both sides, you get 0 equals 0. But that is a true statement. Therefore, every real number that you plug in, no matter what it is, every real number is going to make this a true statement. This is called an identity. The original equation is an identity. 2 times 4x plus 5 equals 8x plus 10. That's an identity. B, on the other hand, x minus 1 equals x plus 7. Notice when you undo x on both sides, so if we have, this one's a little bit shorter, x minus 1 equals x plus 7. When you go to collect your x values on both sides, you would subtract one of the x's and subtract the other. Both of them would cancel out, and it would leave you at negative 1 on the left. This one would cancel out as well, equals 7. You have to check that one's truth value. Is negative 1 equal to 7? No, it's not equal to 7. Therefore, no solution, no matter what you plug in that spot, no solution will give you a correct answer. And a shortcut way to write no solution is to write a 0 and put a line through it. That's considered null. That's the word, or the phrase null set. That means no solution. Null set or no solution. Example number 3 says solving more complicated equations. And not really any tougher. Just like what we did on our bell work, we have some distributive property to work right away, and then some combining like terms. 3 times 2 minus x plus 2x equals negative 5 times x plus 2. 3 times 2, you have to distribute 3 to both. That gives you 6. And 3 times negative x is minus 3x. Plus 2 equals, you have to also distribute negative 5 to these. Negative 5 times x is negative 5x. Negative 5 times 2 is minus 10. So you have 6 minus 3x plus 2x equals negative 5x minus 10. Then combine your like terms. You have like terms, negative 3x and positive 2. When you take negative 3x and positive 2 opposite signs, you get negative 1x or negative x. So 6 minus x equals negative 5x minus 10. Now collect all of your x values on the same side. Negative 1x, as we have on the left here, is a larger value than negative 5x, even though the 5 looks bigger. Remember, the farther you go left, the smaller the value is. So you want to undo negative 5x and bring it to the left. 6 minus x is what you have, equals negative 5x minus 10. You want to undo negative 5x by adding 5x to the right. If you add it to the right, you have to add 5x to the left. So that says negative 1x plus 5x leaves you with 4x on that left, a positive 4x. So now we have 6 plus 4x equals, these will cancel out, and it leaves you with negative 10. Now, since you have positive 4x on the left side, now you want to bring everything else to the right. So you have 6 plus 4x equals negative 10. So bring positive 6. We have positive 6. That's the same thing as plus 6. Subtract 6 on that side and subtract it on the other side to give you 4x equals negative 16, because these will cancel out and leave you with 4x. Negative 10 minus 6 is negative 16. Then that says 4 times x, so divide by 4 on both sides. And it'll give you x equals negative 4. Dividing by 4 here will cancel it. Dividing by 4 will balance it. These will cancel. X equals negative 4. Then we have checkpoint problems. 6x plus 33 equals 5x. Now, typically, you'd want to use 6x is a higher value than 5x. So you'd want to move the smaller 5x over to the larger 6x side. However, there's only one constant term, 33, and it's on the left side of the equation. So move the 6x to the other side. Now, there's more than one way to solve this, so if you did this a different way, it's okay. Get rid of positive 6x by subtracting it. If you do it to the left side, subtract it on the right side. This will leave you with just 33 on the left because these will cancel. 5x minus 6x is negative 1x. Then get rid of negative 1 times that by dividing by negative 1. If you do it to the right side, divide it on the left side. Negative 33 equals, these will cancel, x. 2 says 10y plus 22 equals 8y. 10y plus 22. So that was the way we did number 1. We're going to go back and we're going to do number 2 a slightly different way. Move the smaller positive 8y value to the larger positive 10y value. So in order to undo positive or plus 8y, subtract it from the right, do likewise on the left. This will give you 2y plus 22 equals, this will cancel out, so there's nothing left over there. You represent nothing with a 0. So since you moved your y's to the left in this case, move everything else to the right. This says plus 22. Undo that by subtracting it. If you subtract it from the left, subtract 22 from the right. This will leave you with 2y on the left. These will cancel. Equals 0 minus 22 is negative 22. So that says 2 times y. Undo that by dividing by 2. If you do it to the left, divide by 2 on the right. These will cancel. Y equals negative 11. Number 3 says b equals 9b minus 24. 9b minus 24. So we'll go back to the way we did number 1. Since we have negative 24 by itself on the right already, move positive 9b to the left by subtracting it. If you subtract it from the right, subtract 9b from the left. This is just like saying 1b minus 9b would be negative 8b. These will cancel. Negative 24. Get rid of negative 8 times b by dividing by negative 8. If you divide the left by negative 8, do likewise to the right. It'll cancel the left and give you just b. And negative divided by negative is a positive 3. Get rid of positive 3n by subtracting it. If you subtract it from the right, subtract 3n from the left. Now, a negative 2 minus 3 leaves you with a negative 5n equals, these will cancel, positive 17. So undo negative 5 times n by dividing by negative 5. Do likewise to the right. N equals, because these will cancel, n equals negative 17 over 5. Or if you write it in mixed number form, 5 goes into 17 3 times, and there's 2/5 left over. So this is a more useful answer here. But notice this is it in mixed number form, negative 3 and 2/5. Number 5 says 13m minus 26 equals 13m. So we have negative 26 on the left. Let's bring 13m to the right side. It's positive, so subtract it. If you subtract it from the left, subtract 13m from the right. This will cancel and leave you with just negative 26 equals 13m minus 13m equals 0. You have to check this one's truth value. Is this one a true statement or not? Is negative 26 equal to 0? No, it's not. So there is no solution for this one. Remember, you could write it as no solution, you could write it as that, or null set. All means the same thing. There's no value for m that gives you a true statement there. Whereas number 6, on the other hand, you distribute 6 to both terms. 6 times negative 6, times 4 is negative 24. Negative 6 times negative 2x is positive 12x. Now, before you even go any farther, look and see what's on both sides of the equal sign here. There's a negative 24 and there's a positive 12x. That's the same thing on both sides. This one's going to come out to be an identity problem. Let's see how that happens. Subtract 12x from this side, subtract it from this side, and that cancels it out and leaves you with negative 24. It cancels it out on this side, and this one leaves you with negative 24 as well. Notice that is unlike number 5, that one is a true statement. Negative 26 wasn't equal to 0, but negative 24 is equal to negative 24. That means any value you plug in place of x will make it a true statement. So x equals all real. You say that as all real numbers, or you could write that again as 2 lines like that and make that a capital R. X equals all real numbers. Again, this is just shorthand. This is just the symbol for no solutions. This is the symbol for all solutions. Number 7 says 15a minus 2 times 4a plus 5 equals negative 6a. You have to distribute. Negative times 2 times 4a is negative 8a. Negative 2 times 5 is minus 10. Bring down your 15a equals negative 6a. Combine your like terms, 15a and negative 8a, and you get 7a minus 10 equals negative 6a. Get rid of minus 6a by adding a to both 6a to both sides. Do the same here. And you have 13a minus 10 equals 0. Get rid of minus 10 by adding it to both sides. And you have 13a equals 10, and then get rid of 13 times something by dividing it on both sides. So a's value equals 10 over 13. 1/4 times 12 minus 16q equals 5q plus 6. 1/4 distributes to both. 1/4 of 12, we know that's 3, 3, 3, and 3. So 1/4 of 12 is 3. 1/4 of negative 16q is minus 4q equals, distribute 5 times this, 5q, and 5 times 6 is plus 30. So we got rid of that fraction, and we distributed everything we had to. Move all your q's to the same side. Your smaller value 4q, get rid of negative by adding 4q. Do the same to this side. It'll give you 9q on the right plus 30 equals 3, and these will cancel. Get rid of plus 30 on the right by subtracting it. If you subtract it from the right, subtract it from the left. 3 minus 30 is negative 27 equals 9q. These will cancel. And get rid of 9 times something by dividing by 9 on the right. Do the same on the left. And q equals negative 3.